In this example, we're going to be looking at finding the average rate of change, which the rate of change is this year's slope. But when we call it the average rate of change, it's because the picture is not a constant rate of change, meaning a straight line. For instance, if we have to find Antonio's average rate of change for this race, it's a 4-mile bike race. And the x-axis represents the minutes, and the y-axis represents the distance in miles. So in order to find Antonio's average rate of change, because you could see in green that it is not a constant rate of change, meaning a straight line, we need the beginning point, which is 0, 0, and then the end point here, which is 15, 4. And in order to find the rate of change, we're just finding the slope. So the slope has a formula. The formula is y2 minus y1 over x2 minus x1. So what I need to do is label my ordered pairs. So x comes first always for every ordered pair, and this is going to get the 1s. I chose that to be the 1s. You could switch that to the 15, 4, and you get the same answer. So x comes first and then y, and this will be my 2s. So if I plug this into the slope formula, y2 is 4, y1 is 0. And I'm also going to write the meaning of the change in the y's. So I just read the y-axis, so this will be miles. All right, and then the x's. x2 is 15, and x1 is 0. And the meaning is minutes. So if I simplify this, this would be 4 over 15. And writing the units there. That tells us, if we read this, that it took him 15 minutes to go 4 miles, the entire race. And if we want to, that's our answer. So if we want to actually interpret this another way, so 4 miles, 15 minutes, I can figure out how long it took him to go 1 mile on average again, because again, this is not a straight line. So I could divide by 4. And so this gives me 1 mile, and 15 divided by 4 is 3.75. So on average, it took him 3.75 minutes to go 1 mile.